All right, so let's talk about those glands found in the skin. If we remember, there are two classifications of glands, endocrine and exocrine, and we are looking at exocrine glands in the skin. All right, so all of the ones that we are going to touch on are considered exocrine. Okay, so the first one is sebaceous. So sebaceous gland is going to be found attached to the hair follicle, and the product that it secretes is called sebum. Sebum. That literally just means oil. Okay, but we should be using the proper term. So sebum is what sebaceous glands secrete. Okay, how it's being secreted is holocrine secretion. Holocrine secretion. All right, so if we don't remember what holocrine secretion is, I do suggest backtracking into the, I think, tissues chapter. All right, let's talk about oil. So, sebum or oil, its main purpose is to prevent dehydration of the skin and along with the hair, but it also can inhibit the growth of bacteria, again, by changing the pH of the skin and makes it kind of an inhospitable area for some bacteria. Sweat glands, which are also the proper name for them, is sudoriferous. I If you want to use that term, absolutely go for it. I'm not Sweat glands is fine. Okay. So there are two types of sweat glands in our body. We have apocrine and eccrine sweat glands. Let's talk about eccrine sweat glands first. So, eccrine sweat glands are going to be coiled glands in the reticular layer, typically in the reticular layer of the dermis, and they extend to the top of the skin, the top of the epidermis via a pore, and they are going to secrete sweat, which is going to be really watery and be composed of a bunch of different ions, lactic acid, uric acid, amino acids, glucose, all these different things. We just need to know water and ions. Okay, how it's actually secreting is through merocrine secretion. Right. The cool thing about eccrine sweat glands, these are the ones that actually perform or help with regulation of thermoregulation. Right. Um, the sweat that eccrine sweat glands secrete is odorless. This is not that smelly stuff that, people complain about if we don't, wear deodorant or we work out really hard and then you give somebody a hug and they're like, "Oh my god, you stink." That's not sweat from eccrine sweat glands. All right. But these guys do help with thermoregulation. Now, I also kind of want to talk about something called emotional sweating. So, eccrine sweat glands do release sweat in response to emotional stress like fear or embarrassment. So that's called emotional sweating, or could be referred to as colloquially as cold sweats. Um, it's kind of interesting. It'll start first on the palms and soles and in your armpits or the axillary regions, and then it spreads to other regions of the body. But it does start there. And that's all through eccrine sweat glands. Then we have apocrine sweat glands. These guys are always going to be associated with a hair follicle as well. They're not necessarily attached to the hair follicle like a sebaceous gland is, but they will secrete their sweat through the hair follicle opening. Now, apocrine secretions are very different from eccrine secretions. So apocrine secretion actually has a color to it. It's almost milky, um, and it's going to basically have the similar ions to eccrine, but it'll also have lipids and proteins. So we say that apocrine sweat has or is fatty because of those lipids. Now, This sweat is going to be released via merocrine secretion. Okay, do not get that mixed up. There is an apocrine secretion. They originally, when they first discovered this type of sweat gland, they thought that it was performing apocrine secretions, but later discovered it was performing merocrine secretions. But they kept the name to confuse everybody. So please keep that straight, okay? Both of the sweat glands are going to secrete via merocrine secretions. Now let's go back to that fatty sweat that apocrine is releasing. This is what actually causes body odor because of the way that the sweat interacts with bacteria already present on the skin. It produces that odor, okay? So that interaction with bacteria creates the odor. Now, apocrine sweat glands, again, because they're associated with hair follicles, right? So they're really going to be found, along the axillary regions, the groin, and also around the areola, which is the area around the nipples on the breast. And it can also, these sweat glands can also be found like in the region of a male's face where a beard would be growing. Okay, so if you can, wherever hair grows on a male's face, some is a full beard, sometimes just under the neck, but regardless, wherever that beard hair grows out of, typically an apocrine sweat gland is also found there. Okay, so those are going to be your smellier regions of the body because of that fatty sweat interacting with the bacteria on the skin. Lastly, we have the Serminois, glands. These guys are going to be secreting wax, which is more so in anatomy called cerumen. All right, so that's earwax. So that is going to be found in the ear. Probably could have guessed that one. Anyways, what these guys are is essentially a modified sebaceous gland, and they're used for protection. They can basically trap foreign bodies as well as insects. Gotta remember that. Insects want to crawl in our ear canals so badly, and thanks to earwax, thanks to cerumen, we have something to trap it and to help protect us. Okay, so this wax is going to be secreted via holocrine secretion, just like the sebaceous glands and the sebum. Okay. Also, something to keep in mind with earwax. Wax is technically a type of lipid, which makes it hydrophobic. So cerumen basically is providing a waterproof barrier for in our ear canals. So we also have this protection against fungi and keeping water out of our ear, essentially. Okay, so let's identify these guys. Okay, so basically ear canal, cool. There we have our, sorry, this word always trips me up, ceruminous glands. Oh my gosh. Our cerumen earwax being secreted here, okay? Down here we can see this is a hair follicle. All right, so we can see the terminal ends of the hair here coming out of the epidermis, and attached directly to the hair follicle are a bunch of sebaceous glands. Those are your sweat glands. And then here we have 2D image of our two different sweat glands, our eccrine sweat glands here releasing into a pore directly onto the epidermis, and the apocrine sweat gland, again, not attached to the hair follicle, but secretes via the follicle up onto the epidermis. Okay, so if we were looking at a histology prep of these different glands, would we think that this is an eccrine or an apocrine? So we can see both are coiled, sure, so that doesn't help us. But if we follow that duct all the way up, we can see that it interacts directly with the epidermis. It doesn't connect onto a hair follicle. This is what a hair follicle looks like in a histology prep in the skin. So we don't see that here, so we could identify that as an eccrine sweat gland. All right, let's transition into sensory receptors. Oof, sensory receptors. I love these guys. So these are found all over the skin. We do need to know their location, be able to identify them, and understand what they are detecting. Right? So first we have the hair root plexus. Okay, so we can see that the hair root was that internal portion of the hair follicle, and we can see that there is some sort of nerve ending. Remember, nerves are always going to be in yellow with anatomy. So we can see some type of nerve attaching to that hair root. So we call it a hair root plexus, plexuses, that's plural. This is essentially going to stimulate hair movement, right? So we can't have any movement without some sort of receptor, right? What pulls the hair after the sensory reception would be the erector pili muscle. Okay, but we still need to have some type of nerve ending, some type of portion attached to send that signal to activate the erector pili. Then we have Merkel's discs. Okay, Merkel's discs. So we can see them located here. So these are going to be interacting with the very bottom stratum of the epidermis. Remember that the epidermis has 4 to 5 different layers called strata, right? So the very bottom stratum is going to be where Merkel's discs are located, and this is going to be picking up or sensing sustained touch and some pressure. We also have our free nerve endings. So our free nerve endings, and these guys are different from the Merkel's disc because they actually are going to extend up into the epidermis. Okay, and they are going to pick up warmth or cool, pain, tickling, itching, any type of sensation like that in the epidermis. Then we have that Meissner corpuscle, or again, sometimes just called like a touch corpuscle or touch receptor. I prefer to use Meissner. So this is going to be detecting light touch or even tickle on the skin. And these guys, again, are going to be located in the papillary region of the dermis. So we can see them extending into the dermal papillae. And the lamellated corpuscle, or also called the Pacinian corpuscle, I think I go back and forth with which one I'm using, so you will need to recognize both. These guys are going to be found deep in the dermis or even sometimes in that subcutaneous layer, the hypodermis. And again, they will be detecting deep pressure. So we do have some like a histo image of a Pacinian or lamellated corpuscle, what it would kind of appear like down in the dermis. It's always just kind of shown with like rings and whatnot, as you can see here on the 2D image as well. And in the dermal papillary and the papillary region of the dermis, we can see that Meissner corpuscle or touch corpuscle, touch receptor, very close to the epidermis.